Welcome back, students. In this in this video, we're going to cover Module 6, Topic 6. Notice there is not a Topic 5. Don't ask me, I just work here. So, Topic 6, the triangle inequality. Let me just repeat really quick. This is not a typo. It's not a mess up. There's just not a Module 5 we cover in this course. I think Module 5 for this might be honors only, and we don't get into it, or there's some standard in that particular book, the McGraw-Hill book, for Topic 5 that is not one of our benchmarks and standards. So either way, like I said, Topic 6, the triangle inequality. So we're kind of building off the last video. Last topic was in inequalities in one triangle, I believe. The standard for this particular topic is GR 1.3. The objective, you guys are going to be able to prove and apply the triangle inequality theorem. This is page 14 of the Module 6 packet. I'm recording this prior to the lesson. This is before Thanksgiving. I actually was out the last 2 days. I haven't even written you guys to let you know prior to recording this. And I apologize. We had a nasty stomach bug come through my house, and I didn't leave my room for 2 days, and that's just not like me. So apologies to you guys. Hope everybody's well. So let's get started. Actually, I'm going to pause really quick. I did not grab the proper pen. Okay, sorry, I had to grab a proper pen here. Again, page 14, at the warm up here, topic 6. I'm just going to go ahead and go into this. So we're solving each inequality. So I'll take you guys back sometime in Algebra 1. You may have seen this a little bit before, but I don't know exactly when we start the variables. But we notice we have 2 of these. So these are 2 equations we're going to deal with. So what we do to one side, we have to do to all 3 in this case. So we're trying to isolate x. So we're going to subtract 7 from everybody because we're getting rid of the 7 here. Now I'm going to move this over. But so -3 minus 7 is -10. And that has less than equal to going that direction. Less than equal to. So 5x. Oops. All right, so the 7's canceled. We have a less than going this way here. And then 2 minus 7 is -5. All right, so you with me so far? Now, still trying to get x by itself. So we're going to divide everybody by 5. So 5 here is going to cancel out. It's going to be, well, let me do this here. I'm going to make sure I have enough room. You see, I'm already messing things up. So let's do it this way. -10 divided by 5 is -2. Less than equal to. The 5's are gone. We have just x. Then we have less than here. -5 and divided by 5 is -1. So this is what we end up with for that inequality. -2 is less than equal to x that is less than -1. And I'm going to grab a different pencil because I'm going to run out of room. We're already running out of room. So number 2. So we have the less than here, 3x plus 1 in the middle. So we're going to subtract the 1. This one will be blue. So notice 1 minus 1, this is gone. So we're going to come out here with 3x. Actually, no, it's not gone. It's 0. Duh. Whew. Sorry, math teacher moment there. Senior moment for a math teacher, I should say. 13 minus 1 is, so we got 12 over here. All right, we got to divide everybody by 3. Although 0 divided by anything is 0. 3 here, 3 here. These 3's are gone. You're going to end up with 0 less than x less than 12 divided by 3 is 4. Okay, I got a black pen. Hold on. So number 3. So we have some other stuff going on here. We got the parentheses. We know we're gonna distribute this. I hope you guys remember that. If not, welcome to remedial algebra. So 3x, and then 3 times negative 3 is negative 9. So we're gonna let's just go ahead and do that below. So 3x minus 9, because we distributed the 3, greater than negative 3. Then we've got an or here. We're gonna didn't even notice that from before, but we'll move that over here too. So let's see, we'll say, since we have some space up here, we're just moving number 3 up here. So we have 3x minus 9 greater than 3. So we're going to add the 9 to both sides. They cancel. 3x greater than 12. Divide both sides by 3. And we're going to go up here with this. X is going to be greater than 4. All right, so our other half here. 8x. Nope, sorry. Negative 8x greater than equal to 24. Divide both sides by negative 8. X is greater than equal to, both the negatives cancel out, and that is equal to 3. Why did I? Let's see, hold on, pause. Okay, unpause. So, had to verify something. So yes, when we divide both sides by a negative number, that changes. So this is not correct. It's going to be x is less than equal to 3. Now, negative 24 divided by negative 8 is positive 3, but we changed this sign because we divided both sides by negative. So this would be x is less than equal to 3. Wanted to make sure I clarified that. I admit to imperfection all the time, but just so you guys see it in action. So, excuse me. Now, go back to the red pen. I'm going to scoop this up just a hair. So number 4, it says the temperature in a mixture in a chemical experiment must be between 18 degrees Celsius and 25 degrees Celsius. Write a compound inequality to show the required temperatures. All right, so if the mixture is between something, we're going to put x here. And that means it's going to be, x is going to be greater than this number and less than this number. So this number is going to be the high number, which is 25. And the low number goes over here. So this reads that x is greater than 18 and less than 25. So it's between 18 and 25. Hopefully that makes sense to you guys. All right, so theorem 6.11 is right under the warm-up here. It says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. All right, so let's scoot the page down here a little and let's talk about this and fill in some blanks. So identify possible triangle side lengths. In order for 3 segments to form a triangle, a special relationship must exist among their lengths. So here's the I do, and then we'll do I'll pause, let you pause, do that, and come together at the end. So the I do on the left here. So is it possible to form a triangle with the following side lengths? If not, explain why not. Step 1, check the inequality to see if the 2 side lengths are less than, greater than, or equal to the third side. So for 1A, they give us 3 lengths. They say 9 centimeters, 12 centimeters, and 18. Well, 9 plus 12 is 21, so that is greater than 18. 18 plus 12 is 30. That's greater than 9. And then 9 plus 18 is 27, which is greater than 12. So this checks out. This would be triangle. Excuse me. All right, part B. Let's just do this. This is easier for me. So we have 3 lengths, 3, 5, and 8. So we're going to do the same thing with this. Excuse me. So let's see if these check out. We'll start with the obvious. We'll say 8 plus 5 to 3. So we're using all 3 of these lengths. 8 plus 5 equals 13, so that's greater than 3. All right, let's see. Let's go 8 plus 3 and 5. Again, we're using these 3 numbers. 8 plus 3 is 11. That's greater than 5. So we got 2 out of 3. Looking good. All right. Now let's take the last 2. 5 plus 3, 8. 5 plus 3 is 8. So that is equals. So this cannot be a triangle because of that. They have to, all 3, 2 of the 3 have to be equal to the third all 3 times. Always has to be greater than. All right, so the you do on the right, same situation. I'm going to wait 3 seconds before I begin. Please pause the video here, work this on your own, and then compare the results. All right, you do on the right. Hopefully you did do, and now you're comparing to. See how I rhyme. See if anybody's paying attention to me. Is it possible to form a triangle with the following side lengths? If not, explain why not. Check your inequality. Okay, so 2a. We have 2, 5, and 6. So let's go 2 plus 5 and 6. 2 plus 5 is 7, so that's greater than. Let's go 2 plus 6 and 5. Oops, I'll just give that away. 2 plus 6 is 8, which is also greater than 5. And 6 plus 5 in regards to 2. 6 plus 5 is 11. So yes, triangle. Okay, let's go 2b, or not 2b. 3 plus 4 in relationship to 8. 3 plus 4 is 7, which is less than 8. So we actually know right off the bat, but let's just check the others. 8 plus 4 is 12, which is greater than 3. 8 plus 3 is 11, which is greater than 4, but here's your problem. So not a triangle. Let's see. And we actually put an X over there, but anyway. All right, essential question. How can you eliminate triangle side length possibilities by looking at only one inequality? Cool. Looks like I didn't answer that. So that's a question for us to bring up in class. Bonus points to anybody that asked me that in class to see why I didn't answer it. See, and again, are you paying attention? All right, down below, find possible side lengths of a triangle. When the lengths of 2 sides of a triangle are known, the third side can be any length in a range of values because it has to be less, it has to be greater than the 2. So you have to figure out what that number is, and it has to be greater than that. You'll see. All right, so let me see. Speaking of which, you can't see because I didn't move it far enough. All right. Fencing. Capria is planning to fence a triangular plot of land. 2 sides of the plot measure 230 yards and 490 yards. Find the range for the measure of the third side of the triangular plot. So let's just kind of draw this. It doesn't have to be perfect. So we say that 230 over here and 490. So we need this third. Okay, well the third again has to, all 3 have to be greater, and this is 90, not 49 degrees, and that's 230, not 23 degrees. I know. Hey, let me just zoom that a little. Okay. Switch pens here. All right, so we're going to find the range. So remember, when it's going to be between these 2. So we're going to say N instead of X for once. Live dangerously. So N has to be greater than 230, the lower number, 30, and it has to be less than the bigger number, 490. So your inequality would be 230 less than n less than 490. All right, and then down below here, 3B, what are the minimum and maximum lengths or fencing Capri will need? Hint, use the perimeter. So for the perimeter, that would be all three sides. Well, if we know that, let me see, how did I figure this out? So the perimeter would be at minimum this plus this. So that's going to be the lower number, because it has to be greater than that. Because if this other side is only 1, which is still less, it would fit those criteria. No. Anyway, just bear with me. I'm having a hard time explaining this tonight. So finding our perimeter. So 230, we're going to just do this over here to the side. 230 plus 490 is 720. So it'll be 720 greater than, and I'm going to say P here because we're going to use it in the perimeter, P, and then 490 plus 490 equals 980. So less than 980. Okay, let's flip over page 15. Let's zoom out just a little. Maybe a little more. Okay, page 15. This is a we do, which means it's a me do, but then you follow along, hopefully. And number 5 is an I do. Below, we've got another I do and a you do here. So that'll finish out page 15 with, I think, yeah, this is only a 2-page thing, so it's pretty quick. The next lesson, I could actually have combined them into one, but I'm thinking shorter videos, you guys may be more likely to watch a little more. Yeah, we'll see. All we can do is hope for the best. All right, number 4, page 15. A delivery company uses drones to make speedy deliveries around the city. The drone leaves the home office, flies 8 miles to the east to its first delivery, and then 4 more miles southwest to its second delivery. What is the least possible whole number distance the drone will fly to return to the home office? So we're saying whole number, which means they don't want a fraction or a decimal. So we're either going to round up or round down or whatever we need to accordingly. It says let X represent the third side of a triangle. All right, so let's see. Looks like all we did here, this is, yeah, so for this one, it's 4 plus 8, that's 12, which is greater than X. So X is less than 12. For this, we need to subtract 4 from both sides. It's going to make X greater than 4. And then over here, we're going to subtract 8 from both sides, and X is going to be greater than negative 4. All right, number 5. Well, this is a you do. Please pause the video here. I'll wait 3 seconds before I continue. Try to work the problem. This is going to be an inequality similar to the ones we've been dealing with, and then we'll catch up together. All right, number 5. The distance between New York and Boston is 187 miles. The distance between New York and Hartford is 97 miles. Hartford, Boston, and New York form a triangle on a map. What must the distance between Boston and Hartford be greater than? All right, so remember, all 3 have to be greater than the other. So what we're going to do is we're going to take 187, because that's the bigger of the 2 we have, and we're going to subtract it from the smaller. And that equals 90. So that means that the distance between Boston and Hartford has to be greater than 90 miles. Excuse me. Because, so if, let's say let's do this. Give me just a second. Up here. Let me just take a little piece of paper here. I wanna do something. So remember, if they have to all be greater than the second, so let's say we have 187 plus 97. So if we're saying it has to be greater than 90, let's say it's 91. We're going to use these three numbers. So we're going to add these two. Of course, these are bigger than 91. Let's do 187, the two obvious, and 91. Of course, those are greater than 97. But the other one, 91 plus 97, 187. So 91 plus 97 is 188. And that's why we have to be greater than 90. Because 90 would make it 187, which is equal to 187, which means no bueno for our triangle there. Okay? Wanted to make sure I explained that. I was a little shaky on my delivery, and I apologize. All right, so 15 still. We're going to scoot up the page to the left. Always to the left. Everything you own in a box to the left. Again, who's paying attention, All right, using the triangle inequality theorem. I'm going to do a couple of proofs here. So on the left, number 6, we're given that HC is equal to HB. What does equal mean? It means congruent. So HC is equal to HB. We're going to prove that HA and AB are greater than HC. Going back to our triangle deal. All right. So first statement is given, which was HC is equal to HB. Cool, not in the word bank. Well, it should be this, I believe. Yep, actually, I see a correction from last year. Man, that I missed again this year. Good grief. HC is equal to HB. Okay, boom. All right. Let's see, HA plus AB is greater than HB. So, oh yeah, so one side plus this side means that this side has to be greater. No, these two have to be greater than the third. So that's triangle inequality theorem. It's going to be inequality. Can't fit that. You couldn't see it anyway. I didn't. Sorry, I have a terrible producer. All right, number 3. HA plus AB is greater than HC. So HA plus AB. I feel like we just talked about that. Is it another typo? Oh, well, no, if these two are congruent, that's going to be congruent. And these are both going to be, yeah, so what? Oh, I tell you guys not to overthink, and while I do it. So we went from AB to A. So all we did was substitute. Whew. Now you guys know that I don't look at last year's notes. They're there, but I try to give this to you like we're in class as best I can. So that's the good and the bad and the ugly for the doing it this way. All right, number 7 is a you do. Please pause here. I'm going to wait 3 seconds. You know the drill. All right, number 7, complete the proof. BA is congruent to CA. Man. Okay. So we're trying to prove that CD plus DA is greater than BA. So CD plus DA is greater than BA. Yeah. So because it's going to be greater than this, you kind of, spoiler alert, it's the same thing as over here. All right, so number 1 is the given. Given. Number 2 is blank blank. So it was this over here. Let's see what we have down here. Well, it's not this. Well, maybe. Hold on. No, let's see what we got here. We have definition congruent. Well, if we were going from this to BA equals CA, but we're not going there yet. Actually, yes, we are. Good Lord. Hint to the math teacher, pay attention or read the problem first before you start delivering it. I told you guys I'm serious. This is just, like I'm better prepared in class, but I'm hoping you guys watch these videos and actually may get more out of it, because you'll see me make mistakes that I have a hard time making in class. Congruent segments. So remember, the definition of congruence is equals. So when we swap from this to this, okay. All right, number 3 is the triangle inequality theorem. Well, we have that over here. So this is going to be one of our, here we go. CD plus DA is greater than CA. And it's a, what they call in teaching, I think, aloud or whatever. So I'm thinking it out, and I'm hoping it's helping you to think that way too. If the only way I can let you hear my thoughts is to say them out loud, and that's kind of what I do. I do this in class, but I feel I do it more here, I guess, because there's nobody knocking at the door and nobody asking for a hall pass. Anyway, off my soapbox. All right, number 4. This short video just became a long video because I say all the words. Notice here we have CD plus DA, which is what we're looking to prove. We're looking to prove BA. We just substituted because these are congruent. And that's substitution. And that is the end of the video. Hope you got something out of it. Happy Thanksgiving to everybody. I'm going to make 6-7 real quick and then calling it a night. Again, my apologies for disappearing. I was extremely sick. I hope everybody is well, and hope that came from my kids' school and not First Coast, because I don't wish it on my worst enemy. So happy Thanksgiving and have a good night until the next video.